you to talk about the big difference between an odd degree function and an odd function, an even degree function and an even function. So what's funny is even though they sound very similar, we have to be very careful and very specific as to which one we're talking about. When you go into these assignments, up here, they're talking about odd and even functions. But when you get down here, they're asking about odd and even degree of a function, okay? So we have to know the difference between the two because there is a little bit of a difference. So I've been thinking about the best way to explain it. And here's my best shot. Even functions are a special type of even degree function. So there's even degree functions and odd degree functions. Okay, so it's two big umbrellas. Underneath them are special types called even functions and odd functions. So let me tell you the big difference and a little bit about them. So even degree polynomials, those even degree polynomials have end behavior that goes in the same direction. So on the ends, they can go up on both ends or they can go down on both ends. And how we know is about the leading coefficient. If it's a negative coefficient, on the right side, it's going to be going down. If it's a positive coefficient, on the right side, it's going to be going up. Okay. So even degree polynomials do the same thing on the ends. Even degree polynomials. But you'll notice their center could be anywhere. This is centered right here. This one doesn't have any kind of symmetry, right? This one doesn't have any kind of symmetry. This one is centered right here. Even function is a special type of even degree polynomial where the even function has some symmetry about the y-axis. So even though this is an even degree right here, an even degree polynomial, this one, it's not an even function because it's off center. Okay. This one is an even function. The ends go in both directions and it's symmetrical. It's a mirror image about that y-axis, right? I could take this and flip it over onto that side and it would be the exact same. So it's symmetrical about the y-axis. Now, that graphing characteristic of even functions comes from the definition that when you plug in any x, like let's say this was 5, and you go up and you look at the y value, if you plug in negative of the same number, so let's say this was 5 and negative 5, if they're the exact same y value, then it's even. So if you plug in x or if you plug in negative x, if you get the same answer, if they're equal to each other when you plug them into the function, then that's the definition of what makes a function an even function. Even degree polynomials just have to have the highest exponent an even number. Okay, highest exponent is an even number. And the ends, one of the things that's true is that the ends go in the same direction. Odd degree functions and odd polynomials, or odd degree polynomials, and odd functions, it's similar that an odd function is a special type of odd degree. So there's odd degrees, and then underneath that, there's a special type in there that's called an odd function. And any old odd degree polynomial, the highest exponent is an odd number, like 5, 3, 7, 9, 11, 13. And when you look at the ends of the graphs, they're going to go in opposite directions. So one goes up and down, one goes up and down, one goes up, one goes down, one goes up, one goes down. And to know if it has a positive leading coefficient, you look at the right side of the graph. If the right side is going up, positive. If the right side's going up, positive. The right side's going down, negative. The right side's going down, negative. And when I say leading coefficient, an example of that would be something like, see if I can zoom in enough so I don't have to write like a crazy woman. Let's see, 5x cubed plus 2x. This is a positive number out front. That's the leading coefficient, right? If I make one over here, negative 7x to the 5th minus 2x squared, doesn't matter. This number right here is a negative leading coefficient, okay? So the leading coefficient is a number out front when you write out the equation, not the exponent, not the letter. And the leading coefficient tells you what happens on the right side of the graph. Okay, tells you what happens on the right end of the graph. If it's a positive number out front here, it's going to go up. If it's a negative number out front here, it's going to go down. And that's true if it's an even or an odd function, by the way. Notice what happens on the right side. When it's positive, it's still going up. When it's negative, that right side is still going down. So when you're talking about the leading coefficient, the right side is what you look at. Positive should be going up. Negative, it should be going down. But when you're talking about even and odd degree and even and odd functions, even and odd degree on a graph, opposite directions. In an equation, highest exponent is an odd number, like 3, 5, 9, 11, 12, 11, 13, 15. Odd function, though, that's different, okay? So an odd function, when we look at the graph, it's still going to be up and side, or one side's up, one side's down, but it's going to be symmetrical about the origin, okay? About that center line, right, or that center point right there. And so that's kind of a harder thing to look at. It's harder to visualize. So I like this picture because they show you whether you plug in a positive x or a negative x, what happens is if I plug in a positive x, I get some number. And if I plug in a negative x, I get the same number, but down here in the negative zone. Okay, so let's talk about a couple examples of both even and odd degree and even and odd function. So this question right here under odd and even polynomial functions, not degree, but function. And they're saying determine whether the function is even, odd, or neither. I lost my place real quick. Okay, so even, odd, or neither. And I typed in that equation right here. Okay, and I'm looking at the graph. And to determine if the polynomial, if it is an even function, then we need to see, does it have symmetry? And what kind of symmetry does it have? Another way to look at it, though, would be to actually plug in some numbers. And if we plug in, pick a number, any number, and do the positive and the negative version of it. So let's pick, I don't know, 6. Okay, I get an answer. Now I'm going to plug in the negative version of that, negative 6. Are they the same? Are they the same but different signs, or there's no connection? Well, I don't see an obvious connection in those two. So that would be neither. And as we look at the graph, if it was even polynomial, if it was an even function, then it would be symmetrical about this y equals, or the y-axis. Well, it's not, right? It's way up here and it's way down here on the sides. If it was odd, then it would be symmetrical about this point, not this one up here. So it's neither. Okay. All right, let's try another example. Let me make sure I got the right answer. Didn't make any mistakes. Haha, we're good. All right, next one. Well, the highest exponent here is 4, so I would expect it to be even, but that doesn't mean it is, right? Because 4 is an even number. So let's type it in. 7x to the 4th minus x squared plus 9. Okay, now remember, this is definitely, oh, and let me call it f of x again. This is an even degree because the ends are both going up and the highest exponent is an even number. But that does not mean that it is an even function. What makes it an even function would be, let's pick a couple numbers. Let's pick, I don't know, 9 and the opposite there. So f of -9 and see if we get the same answer. We do. Okay. So same answers here means even. On the graph, if it's symmetrical about the y-axis, that means even. So this one is even. Okay. Now, when they explain it, they do something smart, which they don't use a number, 9 and -9. They use x instead of f of 9 and f of -9, they use x and negative x. So they know it's true for any number instead of just a specific number. And then they simplify it. And see how they started out with this equation, and when they plugged in the negative, they got the same equation? That means that it is even. Okay? If we go back to what I was writing on here, we talk about this specific example. And we think through it again, and we go, okay, so even or odd degree is going to be simple. Is the highest exponent an even or odd number? And are the ends doing the same or different? So on both of those cases, it's showing us it's even because the ends are going in the same direction and the highest exponent is even. I'm running out of room there. Okay, sorry. Let's see if we can fix that. But even or odd function, what you're looking for is about, if you're looking at the graph, you're looking to see, where is it symmetrical? This one, the line of symmetry is right here on the y-axis. So since the symmetry is on the y-axis, that makes it an even function. Or another way to look at it, if you plug in f of some number, you plug in some number, like I picked 9, and you plug in the negative x of that same number, so -9, if they equal each other, then it's an even function. So depending on what they're asking, you're going to look at different things. Okay, so let's do another example. Next problem. They're asking about even or odd function, not degree. So when I type this one in, first of all, they wrote it in a weird order again, right? The highest exponent should be written first to put it in standard form order. So there's my graph, and it looks a little crazy like this. So if they just ask me, is it even or odd degree? They ask me even or odd degree, well, the highest exponent is 5, so it's an odd degree function. That's easy. If they ask about even or odd function, you look at symmetry. It is not symmetrical about the y-axis, so it's not even. It is not symmetrical about the origin, the 0, 0 point, so it's not odd, so this one would be neither.